Welcome to PreMath. In this video, we have got these two right triangles. This triangle ABC and this other right triangle BCD put together, as you can see in this given diagram, such that they share this side BC, which is 24 units. And moreover, this angle ACB is alpha, and this angle DCB is alpha as well. In other words, these two angles are congruent, and furthermore this side length AB is 3 times x, and this side BD is 2 times x. And now our task is to calculate the area of all this yellow shaded region. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. Before we could calculate the area of this yellow shaded region, we must find the value of x first. And here's our very first step. Let's focus on this right triangle ABC. And we are going to apply the Pythagorean theorem on this triangle to calculate this side length AC. And here's our Pythagorean theorem: a square plus b square equal to c square. And here in our case, this AC is our hypotenuse, whereas 3x and 24 are our two other legs. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got 3x whole square plus 24 square equals to AC square. Let's undo this square by taking a square root on both sides. So therefore our AC side length is going to be the square root of 9x square plus 576. So thus our this side length AC turns out to be square root of 9x square plus 576. And here's our next step. Let's assume that alpha and beta are our two complementary angles. In other words, the sum of these two angles, alpha plus beta, must be equal to 90 degrees. Let's focus on this right triangle ABC. We know this angle is alpha, this angle is 90 degrees. So therefore, this angle has got to be our angle beta. And now let's focus on this other right triangle BCD. We know this angle is alpha, this angle is 90 degrees. So therefore, this angle has got to be our angle beta. And now we can see that these two right triangles, this right triangle ABC and the other right triangle BCD, are our similar triangles according to angle-angle similarity theorem. And since these are our similar triangles, so therefore we are going to have a proportion. So therefore I can write down the ratio of the side length AB divided by BD is going to be equal to the ratio of AC divided by BC. Now let's make an observation. We can see our this AB length is 3x. So I'm going to replace this one by 3x over here. Likewise, our BD length is 2 times x. So I'm going to replace this one by 2 times x. And then our this AC length is square root of 9x square plus 576. And finally this BC length is 24. So I'm going to replace this one 24 over here, as you can see in this next step. And now we can see this x cancels out with this x, and now we are going to cross multiply. So therefore we can write down 2 times the square root of 9x square plus 576 equals to 72. And now we are going to divide both sides by 2. So therefore this 2 and 2 cancels out. So we got the square root of 9x square plus 576 equals to 36. And now we are going to square both sides to undo this square root. And now we are going to subtract 576 from both sides. This is gone. So therefore 9x squared turns out to be 720. Let's divide both sides by 9. 9 and 9 is gone. So therefore our x square value turns out to be equal to 80 on the right hand side. And now I'm going to undo this square by taking square root on both sides. So therefore our x value simply turns out to be 4 times square root of 5 units. So thus our x value turns out to be 4 times square root of 5. So thus our this side length AB is going to be 3 times x, means we replace x by 4 times square root of 5. That's going to give us 12 times square root of 5. And likewise this side length BD is going to be 2 times x, and x value is this one. So that is going to give us 8 times square root of 5. And now let's focus on this another right triangle BCD. And we are going to use the Pythagorean theorem on this triangle as well to calculate this unknown side length CD. And here's our Pythagorean theorem once again: a square plus b square equal to c square. And I'm going to label this side length CD as lowercase y. And we can see our hypotenuse is 24, whereas our two other legs are y and 8 times square root of 5. And we are going to solve for y. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got y square plus 8 times square root of 5 whole square equals to 24 square. Let's subtract 320 from both sides. This is gone. So therefore y square value turns out to be 256. And now we are going to undo this square by taking square root on both sides. So therefore we can see that our y value turns out to be positive 16 units. So therefore our this y value turns out to be 16. And now let's make an observation. We can see this yellow shaded region area is equal to the area of this triangle ABC. We are talking about this ABC triangle area plus the area of the other right triangle BCD. We are talking about this other right triangle. So therefore now our task is to calculate the area of this triangle ABC and the area of this other triangle BCD as well. And now we are going to calculate the area of this right triangle ABC. And let's recall the area of a triangle formula. Area equals to a half times base times the height. And in our case, the base of this triangle is 24. The height of this triangle is 12 times square root of 5. So let's go ahead and fill in the blanks. So we got a half times our base is 24 times height is 12 times square root of 5. And if we simplify this one, that is going to give us 144 times square root of 5. And now we are going to calculate the area of this other right triangle BCD. And once again, we are going to use the very same area of a triangle formula. Area equals to a half times base times height. And in our case, the base of this triangle is 16 and the height is 8 times square root of 5. So let's go ahead and fill in the blanks. So we got a half times our base is 16 times our height is 8 times square root of 5. And if we simplify, that is going to give us 64 times the square root of 5. And here's our final step. Now let's go ahead and calculate the area of this yellow shaded region. We already figured out our triangle ABC area over here and the triangle BCD area over here as well. Let's go ahead and fill in the blanks. So we got 144 times the square root of 5 plus 64 times square root of 5. And if we add everything, that is going to give us 208 times the square root of 5 square units. So thus the area of this yellow shaded region turns out to be 208 times the square root of 5 square units. And that is going to be approximately equal to 465.1 square units as well. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.